Hello everyone, this is Ewin's lab. In the previous video, we learned about our UDP packet structure. But how do we actually send this packet over the network? In this video, I'll explain network communication basics and demonstrate some basic Python socket programming for this project. Let's get started. From this example, we can see the protocol diagram on the left, the sender's log in the middle, and receiver's log on the right. Let's first look at the protocol diagram. You may notice the receiver shows colon 5000. It just have the port number. This is very important because the receiver only specifies the port since it listens on all addresses using that port. We will see how we implement that in Python later. Now, let's walk through the protocol. First, the sender sends a start packet with a random sequence number 3928107. And the corresponding sender's log is 03928107000. Type 0 means start. The receiver responds with an ACK, which has the same sequence number. Then the connection is established. Next, we deal with data transfer with sliding window. As we can see, the sender sends 3 data packets at once, 0, 1, and 2. The window size is currently set to 3. Look at the sender's log. We see 3 consecutive data packets. Each has 1456 bytes. The receiver got all 3 and the window is full. After that, the receiver sends ACK3, which tells the sender that I have received the packet 0, 1, and 2. Please send me 3. This is actually very important because it shows that one ACK acknowledges multiple packets, which makes it very efficient. And then the window slides forward. The sender immediately sends data 3. Here is where reliability kicks in. Data 4 gets lost. Look very carefully at the sender's log. There are 2 lines with sequence number 4. Between them, there is a 500 millisecond timeout. So the same packet is sent twice. But the receiver log only shows data 4 once because it only got the retransmitted copy. This is how the protocol handles the packet loss. And finally, the sender sends AND with sequence number 3928107, the same number from start. The receiver acknowledges and the connection closes. Let's move on to Python socket programming example. Technically, you can use any editor. For this demonstration, I'll use VS Code. First, we open our editor in the working directory. I can either open a terminal and run code /, or right-click, select Open with Code. Let's create 2 Python scripts, a sender and a receiver. I can drag the receiver window to the right side and create 2 terminal windows, place them below each of the scripts. We can begin with importing the socket library. Then we initialize a socket instance. The first parameter is the address family. Here we use AF_INET. This refers to IPv4 family. For the second parameter, we use socket dgram. This refers to UDP protocol. Let's copy this to the receiver side as well. Next, let's create a payload. Say hello world. Also notice I put a letter B in front of the string, which specifies it's a byte string. To send the payload, we use send_to method. The first parameter, of course, is our payload, followed by a tuple of address and port. We use 127.0.0.1, which is our localhost. And remember to close the socket after we are done with it. On the receiver side, we use the bind method and a tuple as its parameter. The first element, we leave it empty, and the second element, we put 5000 here. This means we will listen to all addresses on port 5000. Then we retrieve the received data and address from the socket. We specify 1472, which is our maximum MTU available. We extract the payload with the decoded data and print it out. Run the receiver first, then the sender. As we can see, the payload immediately reaches the receiver. What if we change the target port on the sender's side? Nothing happened because our receiver is not listening to port 5001. Let's change it back. It received the message again. And this is our basic communication. Now let's see how to parse an RUDP packet. First, we define our packet fields. To calculate checksum, we need to import zlib and its CRC32 method. Then we construct our packet data. We just append them one by one. And send the packet data. Here we add a print statement to show the total packet data length. Oops, there's an error. Okay, the payload does not need conversion. It's already a byte string. And obviously, it's not limited to 4 bytes. Let's add more print statement to show what we have sent. On the receiver side, let's extract each of the RUDP packet fields. The packet type is the first 4 bytes. The next 4 is sequence number, and so on. Let's also print them out. Okay, our payload does not need to be converted to integer. And here we have it. Let's also verify our checksum. So we import the zlib again and compute the checksum using the received payload. Oh my, I should definitely play less game. Sorry. Also remember to close the socket. And here we did it. Thanks for watching.